Hey everybody. Today we're doing an example of Bayes' rule. We're imagining a situation where a company has data on customers entering their store. They know the age breakdowns of people that come in. For instance, 24% of the people that come in their stores are under the age of 25. And they know the probability that someone will make a purchase in each of those categories. So for instance, among the people that are 25 and younger, 37% of people that enter the store make a purchase. We'd like to find the probability that a customer who makes a purchase is under the age of 25. Notice that that's the opposite conditional probability from what we already have. We know that the probability that someone who's under 25 makes a purchase is 37%. We're going to use Bayes' rule, of course, which in its simplest form says that the probability of B given A is the probability of B times the probability of A given B all over the probability of A. Obviously, this rule only makes sense if that denominator on the right is non-zero, which is the situation where the event A is actually possible. Roughly speaking, Bayes' rule tells us how to update the probability of some event B, in our case that event is going to be that the customer is under 25, once we know that some other event A has occurred, and in our case A is going to be the event where the person actually makes a purchase. Bayes' rule is often recast using the law of total probability, which basically tells us how to evaluate that denominator, the probability of A. And it does that by partitioning the sample space into non-overlapping sets, B1 up to BR. In our case, we're going to partition by age. So we're going to have four events, B1, B2, B3, and B4, corresponding to the different age categories. Ultimately, we're going to be interested in the probability of B1, that the customer is under 25, given A. In other words, that they've actually made a purchase. Here's a visualization to help clarify what's going on as we compute the probability of A using the law of total probability. We have this partition, B1, B2, B3, B4. Those are the different age groups, partitioning the sample space. You can see that on the left. And so then we have this event A, which is going to be that the person makes a purchase that then is partitioned by A intersect B1, A intersect B2, etc. So the person makes a purchase and is under 25, etc. All of the probabilities now are things that we have from the table. We know the probability of B1, B2, and B3, and B4. Those are just the probabilities that the person is in the certain age group. And we know the conditional probabilities, P of A given B1, etc. Those are just the probability of purchase within each of those age groups. Plugging in and simplifying, we get the probability that the person is below the age of 25, given that they made a purchase, is about 33.9%.